the problems that you are going to encounter over the next couple of days are going to look like this right here, where we have a trig expression set equal to a trig expression. And our job is to show that those two trig expressions are indeed the same. Okay? Yes, I did say prove. A lot different than what we've worked with as far as proofs in the past. Okay, it's not like your geometry was proved that we do. Okay. Three different ways that you can do this. Okay? Our end goal is to get both sides to look the same. When you have both sides that look the same, you have proof that those two identities are indeed equivalent. Okay? So, what can you do? You can take the left side and you can manipulate it until it looks like the right side. And when I say manipulate, I mean what we did in our homework last night. Use trig identities in combination with some algebra to change the way that it looks. Okay. Second way you can solve these problems. What is he going to say? Manipulate the right side until it looks like the left side. All right, I said three ways. First way, manipulate the left side until it looks like the right. Second way, manipulate the right side until it looks like the left. What could possibly be the third option? Manipulate both sides until they look like each other. Okay? Your answer isn't secant x equals secant x. Yay, I did it. Okay? Your answer is every single step in between. Okay? Now the beauty of this is that we all can do the same problem, and each of our proofs may look different. As long as they are mathematically sound, it's okay for all of ours to look different and still get to the end of the proof. Okay? Now, there are going to be problems where it's a lot easier to do it one way as opposed to the other. But those are things that you'll kind of learn as you do more problems. Okay? Now, when I say manipulate, and I don't know if you necessarily need to write this down, but the 8 fundamental identities, so the 3 groups of identities that we wrote down at the beginning of class on Friday, the 3 groups of identities that will be the first question on your quiz Thursday, those are the identities that you have to know in order to be able to manipulate. Okay? Also, algebra skills. Okay, we worked a little bit with factoring on Friday. Okay, there'll be some factoring that pops up, making common denominators to add expressions together, being able to reduce a fraction. Okay, those are the algebra skills that I'm talking about. Now, this is important. We are proving that these two expressions are equal. This is not an equation, okay? Which means you cannot take something and move it to the other side of the equation. That is not what we can do, okay? We are not solving an equation. We are proving that two expressions are equal, okay? So maybe we, instead of the word equal, we use equivalent. We're proving two expressions are equivalent. Okay, and we want to keep everything separated. So what's on the right side stays on the right side. What's on the left side stays on the left side. No moving across. Okay. Now, some hints as far as how to attack these problems. Okay, what's nice about these problems compared to Friday is that once you get both sides to be the same, you know you are done. Whereas maybe in number 43, you didn't know where to stop quite yet. Okay. You already did Friday's assignment. Well, most of you did Friday's assignment. Okay. Was it challenging? Okay. Did it make you think? Okay. That's not going to stop. Okay. You are going to have to be very thoughtful in these problems. It's kind of like solving a puzzle. Which move should I do first? And is it going to be helpful or is it going to be harmful? Okay. It is okay to do something and erase it and start over. Okay. You may have to do that. Some things that I may suggest. If one side looks more complicated than the other, it may be easier to take the more complicated side and start manipulating it into something simpler. Okay? If you only have cosine of x on one side and a big jumbled mess on the other side, it's a lot easier to work with that big jumbled mess. Okay? If one side has addition or subtraction and one side has multiplication or division, it may be easier to work with that addition or subtraction with our common denominators adding together sort of stuff. Or, maybe you see the multiplication or division you can break up to help you get to the addition or subtraction. But oftentimes, if there is addition or subtraction, you're going to want to look for that common denominator to add them together or subtract them. Okay. You always need to be looking for opportunities to make those substitutions with your trig equations. Okay. Sine squared plus cosine squared should pop out to you like a big red flag. Like, ooh, I can make that one. Okay? Or if you see sine over cosine, you know that you can change that to tangent. Or vice versa. You see tangent, you know you can change it to sine over cosine. All right? So just always be on the lookout for things that you can change with those identities. Okay, factoring will be a big part of this. Okay, if two terms have something in common, we can factor that common factor out. Okay, if you have a trinomial, maybe you can factor that into the multiplication of two binomials. Okay, I want you to look for those things. It's not going to happen often. Probably the more frequent kind of factoring will be a GCF. Okay, so don't forget about that. Okay. Combining fractions. Okay, if you have two fractions added together, make a common denominator and combine them. On the flip side, maybe you have one big fraction that you can break up into two or three fractions. Okay, you have two terms in the numerator, 1 plus tangent theta. Okay, we can't do anything with the numerator, but if we maybe split it up into two fractions, maybe you can do something with it. Multiply by the conjugate, that is something that we talked about a little bit on Friday. Okay, if you have 1 minus sine of x, 1 minus cosine of x, if we multiply by the conjugate, we create that Pythagorean identity in the denominator. Okay, my biggest piece of advice is to not give up. Okay, like we talked about on Friday, this is probably going to be uncomfortable for you for a little bit, and that is fine. Okay, it's how we grow, it's how we build character. Okay, if you try something and it doesn't work, that's fine. Take a couple steps backwards, try something different. Or maybe if you get stuck on the right side, go to the left side. See if you can get the left side to look at what you've done with the right side. Okay.
On the quiz, are there going to be some that don't equal each other?
No. I will always give you two expressions that are equivalent. Always. Okay? You will always be able to prove that they are equal. Okay? Now, something that I do want you to do is I want you to explain your step to me with each step that you do. Okay? Why am I making you do that? Each one of you could attack a problem differently. And I'm not looking at just, oh, they got there. I have to make sure that you got there mathematically correct. And so I need to look at each and every one of your steps. If you can explain to me what you did, it is helpful for not only me to look at what happened from step to step, but it also is justifying it to yourself, like, okay, I can do this because it's an identity. Okay, I can do this because I did some algebra. Okay? So it's not quite as formal as your geometry proofs, but I still want you to at least tell me what you did in each step. So I can follow along, you can follow along, your peer can follow along if they were to look at yours. Okay? So we're going to start with what I had on that very first slide. And just because we do it one way here in class doesn't mean that is the only correct answer. Okay? Now, without actually writing anything down, I'd like you to take just a few moments at your pod and talk about some different things that you can do. Which side do you think you would want to start on, and what could you do with that particular side? Ready, set, go. Okay, it sounds like our conversation is semi-over. Pod 3, what did you guys talk about?
We said start on the left, and then make it sine over cosine plus cosine over sine.
Okay, how many of you discussed starting on the left side? Okay, I think that was one of my suggestions. If you have addition versus multiplication, starting with the addition side may be easier. So pod 3 suggested we can take tangent and change it to sine over cosine, and cotangent and change it to cosine over sine. Okay, what did we just use? Okay, so next to that step, I'm going to write quotient identities. Okay. All right, suggestions from the crowd. What can we do now with that left side? How? Okay, so you are suggesting that we make common denominators. Okay. So, we need to take the sine of x over cosine of x and multiply it by sine of x over sine of x. And we need to take the cosine of x over sine of x and multiply by cosine over cosine. Okay, so I'm just going to put here that I'm trying to make common denominators. I can't fit it, but you know this. Okay, so now that we have common denominators, we can combine our fraction into one. Okay, and that's what I'll describe. I'll say that we are combining fractions. Okay, we're taking the sum, we're combining it to one. Okay, notice also how I'm doing something just one step at a time. I don't want you to do too much in one step. At this point, some of you are going to see the path of how we're getting these two to be equal. And that's wonderful. But you still have to do things one step at a time. Okay, you can only do one thing at a time. Now, what do you notice? Chris?
You can change it to one Pythagorean identity.
Okay, our numerator, and this is something that has to jump out at you, okay? It just has to, because it happens so often. Sine squared x plus cosine squared x is 1. And that is a Pythagorean identity. And if you write Pythagorean and you don't write the word identity, I know what you mean. Yes.
Could you right now just flip it and make it equal? Or do you have to, like, split the two and make it 1 over sine of x?
I can be flexible either way.
So you could just put it up here.
Okay, yes. Yes. We know that 1 over sine is cosecant, and we know that 1 over cosine is secant. Now, what did we use, Caleb? What did you suggest? Right, what identity was that called? I'm gonna make Caleb look it up. It's another word for flip it.
Reciprocal.
There you go. Those are the reciprocal identities. Okay? Now, this I don't like. Do both sides look exactly the same? No, they technically don't. I would prefer that you rewrite it to be secant x cosecant x equals secant x cosecant x. They look exactly the same. All we did was use the commutative property there. But I do want both sides to look exactly the same. Once you have both sides looking exactly the same, you're done. Okay? Now, in this particular problem, we only worked with the left side. And that is fine. Some of you may get to here, and you instead change the right side to look like the left side. That is fine. Okay? Some of you are going to be very against doing both sides. Some of you really just want to stick to one side. That's fine. Okay, like I said, there's going to be a million different ways we can do these problems. You do what you see and you do what you're comfortable with. Okay? All right. Please write this one down. Okay. Same thing as last time. I want you to take a moment and discuss which side you think you would want to start with and what you would do. All right. Side 2, what do you think?
Keeps the Pythagorean identity on the right side instead of the
Do we have 1 minus sine squared? No. Which means we cannot use the Pythagorean identity yet. Okay, and this is something, Nick, I'm very glad that you brought up. Because it's very tempting to want to say that this is something, 1 minus sine, but it is not. It has to be 1 minus sine squared, okay? Now, since it's only 1 minus sine, there was a suggestion that I gave to you on Friday. Do you remember what it was? Go back to one of our examples from Friday. If you have your notes out.
Multiply it by. So, plus sign.
Yes. Okay, we can take that denominator of 1 minus sign. It's almost a Pythagorean identity, but it's not. We can multiply by the conjugate. Okay. So what we have is 1 plus sine of t over cosine of t equals cosine of t times 1 plus sine of t all over 1 minus sine squared. Well, and maybe this is technically down here. I'm really sorry. That should be there. Okay. You got one step down. Eli, you're staring at your paper. Do you notice something? No? Okay. We multiply by that conjugate for a reason. That 1 minus sine squared. Do you have your identities in front of you? Turn to your identities. Oh, you don't have your stuff. That's right. For at least tonight, I would suggest having your identities in front of you until you get kind of used to seeing things. Okay? So I'll cut your break here, Eli. Okay? Chris, what can we do?
Pythagorean identity to make 1 minus sine squared t for cosine.
All right. Do you agree that 1 minus sine squared t is the same thing as cosine squared t? Yeah. Okay. So we use the Pythagorean identity. Are both sides the same? No, but we are pretty darn close, aren't we? Yep. Marissa, what do you notice? Okay. This cosine is going to reduce with one of these. Hey. Are both sides the same? Yes. What did we do to that fraction? Okay, if you put reduce, simplify, something like that, that would be fine. I'll understand what you mean there. Okay, we got both sides to be equal. I like to put a check mark just to verify that I am done. Both sides are the same. Okay, once again, we only work with one side. That's fine. All right. I'm going to put one more up here, and I want you to work together at your pod to see if you can get to the end. Okay? Yep. That is quoted. Work together. In like 1 minute. Okay. Let's see if it's for minutes one. Okay, good, good. My suggestion to you is that the public participation would be available in place on. It's not an identity, so it's not. Yeah.
Well, we're stuck.
You're done? Yes. What did I tell you? There's no argument to give up. Okay, I was gonna have different people go up to the board, but the way that Nick did it seems to be the route that everyone's attending. Okay, the first thing he did was he took that numerator and changed it to tangent squared theta. I know that was a lot of people's first step. Okay, some people got stuck here. If you're at a place and you're not really sure where to go, I'm going to tell you two things. Changing your denominator to have two terms isn't helpful because you can't split up your fraction. Okay. Second thing, sines and cosines. Looking at an identity in terms of sines and cosines can be helpful. Okay. Proceed. Okay, now some of you may not have used the reciprocal identity the same way that Nick did. I did walk around, thank you, Nick, I'll let you sit down. I did walk around, some of you left like 1 over cosine squared as your denominator, and then did the simplification, and that was fine, okay? So he took secant squared and reciprocal, moved it up to the numerator as cosine squared. Tangent's the same thing as sine over cosine squared, okay? So the cosine squared cancel and we leave it as sine squared, okay? Now, this is not the only way to do this problem, and I'm actually surprised that I didn't see anybody try this. Maybe I just didn't walk by the right piece of paper, but on the board, on the whiteboard, I have a different way, okay? Since there are 2 terms in the numerator, it is okay to break this up into 2 fractions, right, with the same denominator. And so then secant squared over secant squared is 1, 1 over secant squared is cosine, and then you have the Pythagorean identity, okay? These 2 look completely different, but they get you to the same thing as far as both sides are equal, and so they're both legitimate proofs. Okay. Let's talk about your homework tonight. You have, and I can't remember how many problems, not too terribly many. Oh, I don't even have the right gold sheet here. You have four required problems, 2 non-required ones. You may want to do more than just the 4 bolded ones. Okay? Now, in the back of the book, it's going to say answers may vary. It's not going to be helpful. Okay? So this is one section where looking in the back of the book isn't going to be a good strategy to check your answers. Okay? I will tell you what will happen tomorrow. The sub will give each pod a piece of paper with my solution. Now, just because it's the way that I did the problem doesn't mean that it is the only right answer. You could have done it differently, and that is something, if you're not sure if you did it mathematically correct, I would have your neighbor look at it. But could you guys listen to me? There's still an entire 2 minutes. Okay? I'm going to give you 10 minutes at the beginning of class tomorrow to compare your problems with your peers and my solutions that I give each pod. Okay? And then you're going to have an assignment tomorrow that you're going to work on. This is not supposed to be easy, but it is not impossible. You need to go into your homework and your quiz with the mindset of, I can do this. If you get stuck, it is okay. Skip it, come back to it, go to the other side, try something else. But you may not get every single problem right away, and that is not a bad thing. That does not mean you don't know what you're doing. That does not mean you are bad at math. That just means you didn't see it right away. That's all right, we'll try something else. Okay? On Wednesday, when I am back, we can go through questions, more problems. Basically, for the next 3 days, we're just going to be doing problem after problem after problem to get the hang of things. Okay? Thank you.